Hi and welcome back to a new video. You might recognize this location because we were already here about a year ago. Today we will visit Hetzner again, huge data center provider from Germany, but this time we will not visit the server farm or whatever. We will take a look at a very specific ARM-based server. Similar to our previous visit, we are now in the development area of Hetzner. That's where they try out all their servers, investigate new platforms and stuff. And that's why we are here to investigate the Ampere Altra. Right here in my hands I have a Q8030, which is the CPU name, 80 for 80 cores and 30 for the frequency of 3.0 GHz. It also exists as Q8033, but apparently the availability is quite difficult of the 33 version, but I think also performance and especially performance per watt, this is a really interesting CPU. The Ampere Altra Q8030 will sit in the LGA 4926 socket. It's just that there is no special naming scheme, no SP3 or anything, but if you look at a socket, it will definitely remind you of AMD EPYC or AMD Threadripper. That's also why they are using the same screwdriver with the same mounting force. It's using 1.5 Newton meters, while the recommended force is, or torque for the socket is 1.6, so it's very similar, and the 1.6 is also with a certain tolerance. I think it's about 10%, which is why you can easily just use the same torque screwdriver for mounting the the Ampere Altra CPU in this socket. Looking at this, you will also notice that apart from that the mounting mechanism is pretty similar to AMD, the mounting for the cooler is entirely different. You will not be able to fit any kind of standard Intel or AMD cooler on here. And even if you wanted to, if you look at the mounting dimension, it would not work. And why that is the case, I will show you once the CPU is sitting inside the socket. I will try my best not to drop the CPU in the socket and break it like I did with the AMD CPU. I mean, that's a bit different from AMD Threadripper because you don't have this sliding mechanism, but apart from that, definitely reminds me of it. Also, you have 5 screws, not only 4, and they also told me that I should definitely pay attention to the screw order. You start with 1, 2, 3, 4, 5, because if you don't follow the order, it's very likely that you will have some kind of memory detection issues. Now you can also see what I was talking about earlier, that you might see some compatibility issues if you try to mount any kind of Intel or AMD cooler, simply because even if your mounting dimension would fit, it wouldn't fit on here, because you can see the IHS is sitting lower than this loading mechanism, which is quite interesting. And it's also something I think I've never seen on any other platform so far. It certainly will make the processing or the manufacturing of the heat spreader easier, but yeah, you always will have some kind of cooler limitations, compatibility issues, because if we switch over to the cooler they are using, you can see they always have to have this elevated center socket thing in the center. Whereas if you look at any other Intel, AMD, EPYC, whatever thing, they can always be entirely flat. So cooling manufacturing is definitely going to be more expensive. The cooler we just investigated is a 2-unit cooler. It is a bit beefier than the one which we will use on the system which is running in the background. It also shows that these CPUs, even though it's ARM-based, still has a certain power draw. It is listed with a TDP of 210 watt, at least for the 3 GHz version. The 3.3 GHz version would be listed with 250 watt TDP. But as we often discussed, TDP doesn't necessarily mean that it's the peak power consumption, because when we run Geekbench later, we will also see that the power draw can be a bit higher than that. One thing that sets the Ampere Altra apart from a typical Intel or AMD system is the fact that it's based on ARM. It's an ARM V8 CPU, and ARM is something, if you want to say it easy, it's a different instruction set. So for example, the Intel and AMD CPUs, they are all based on x86. This is based from the early Intel days when they had the 80, 186, 286, 386. At a certain time they started to just get rid of the 80 in front of it and just added x86. That's why it's called that way. But then you also have, for example, IBM Power. That's also something we already checked in previous videos. And then you also have ARM. ARM is something that is created by a company which is not making chips themselves, but they are making the instruction set. And the Ampere Altra is an ARM-based CPU, which is also why we are limited in the programs we can use. Like everything you see on, let's say, Intel, when you run your typical Windows with Steam and you want to run like 3D Mark and Cinebench, all of these programs are x86 based, which means that we cannot simply run this on this server. But luckily, Geekbench 5, because it's a cross-platform benchmark, we can also run Geekbench 5 on here. You might notice, for example, from mobile devices, there are like tablets and handheld devices, mobile phones, which are based on ARM. And there you can also compare your performance with Geekbench 5, which is why we are going to do that on here. I can promise you that the performance is absolutely impressive. Especially if you compare this, let's say, with an AMD EPYC or Threadripper. You also have, for example, 128 thread CPUs. But for this, let's say, if you would use the 128 core CPU, it's using native cores. Like one core is one thread. It doesn't use SMT, which is why it has a massive multi-threading performance. And here we have the running server. As I said before, it's using the same CPU, so the Q8030. Quickly overview over the Hetzner cooling solution. They always make their custom cooling brackets for efficient cooling of, let's say, memory DIMMs and also the CPU. We can quickly take a look at the CPU cooling solution. So unplug the fan and this like fan tunnel, I would call it, for channeling the air. And here we can see that the cooling solution, the heatsink, is a bit different from the one we just saw earlier. It's a bit more compact, has a different heat pipe orientation. The heat pipes are vertical, just going upright. It's a bit more compact, as I said before. Right now, this is no problem to run it without a fan, because as you can see, we already hooked up an Elmore PMD, which Hetzner also bought. It's pretty awesome. And the CPU idle power draw, like that's just CPU, nothing else, is between, let's say, 30 and 40 watt. So that's totally fine running the heatsink for a few seconds without the fan, no problem at all. Memory-wise or DIMM-wise, we are running octa-core configuration, so 8 DIMMs, 4 on each side. Technically, the Ampere Altra supports up to 16 DIMMs and 4 terabyte max capacity. When it comes to storage, Hetzner is working with OcuLink, even though that there are M.2 drives or M.2 slots available. Like underneath the fan, it's a bit difficult to see, but underneath here would be M.2 slots, at least for the mainboard. But they decided to go with these OcuLink cards, and technically they can hook up to 4 devices per slot, which makes sense. It's 4 PCI Express lanes per cable. And then right here we have these 2.5-inch drives. The reason why Hetzner is testing the CPU here is obvious, because they want to have this also listed as dedicated root server. Very similar to what you saw in some of our advertising spots when we were advertising AX like 41 dedicated root servers. They will have this configuration also available as a dedicated root server. And then when it comes to storage, you can select from 0, well, base wouldn't make much sense, but up to 8 NVMe SSDs, each of them 3.84 terabyte size. As you can see, we are now running Linux, and we will now run Geekbench 5, but due to the fact that on Linux you have to run it with the command, so we don't have the nice graphical interface, but that's no problem at all. On the right side you can see the total system power consumption. That's an external tool made by Hetzner, so they have this monitoring available right here, so that's not like mainboard monitoring or anything like that. Total system power consumption, so everything included, like PSU switching losses, VRM switching losses, DRAM and everything. In case you're wondering, the CPU is an SoC, that's why it's reading SoC temperature. But let's just run the benchmark and see what kind of performance we can get. First of all, we are running the single core bench, as you can see on the left. That's also why the power draw, the total system power draw, did not really change that much. It went from like 80 to 90 to like 95 to 100. So it's not a big change, only loading one core, also no big change in temperature. But that will drastically change once we run multi-core. Now that we are running the multi-core, you can see it changed a lot. It just went down because it's running a different subtest. But here you can see, for example, it went to 220 watts, now it's here 270. But that just purely depends on the subtests it's running. We saw peak power consumption right here of about 310 watt. Quite interesting is that the temperature is still quite low. Even though we're running height-low, like 250 watt right now, it's only like 65 degrees Celsius. And here we have the final result. Single core score is 882 and multi-core is 44,425. And for your reference, because not everybody might run Geekbench 5 every single day, the current record that is set on HWBot is with Threadripper 3990X, overclocked as well, and it scores about 34,000 points. So this system has a higher score by about 10,000 points. And now we also have to go back to the point of system power consumption. What you saw on the right was the total system power consumption, as I said before, about 310 watt peak. But that's total, like switching losses of PSU, switching losses of the VRM, memory and everything. And we also checked in between with the Elmore PMD, and the power draw there, just CPU, pure CPU power draw, was about 170, 180 watt. Now, if you look again at performance and power consumption, the efficiency is insane. It's like twice, it's like double compared to a current Threadripper or EPYC CPU, because as well, the 3990X is a 64-128 thread CPU. Pretty impressive. This is kind of the end of the video, but also not, because Hetzner allowed us to take this CPU with us home, so we can delete the CPU. Back at home, now time to delete the CPU. Right now we have no idea if the CPU is soldered or if it's using conventional thermal paste, which means we will first try to use a razor blade, cut around the IHS, see if we can get it loose or not, and then we will figure it out. Yeah, well, that just didn't work out, just with the razor blade. Not sure how the CPU is internally built. It could be similar to a Threadripper, it's also TSMC 7nm, but yeah, just simple cutting around the edge didn't work. Now you can see we're back at our workshop here at Thermal Grizzly, and whenever we are doing those videos, I'm finding out that we lack equipment. This time I figured out that we're lacking the equipment for the vise, because you typically have these things, I'm not sure how they are called, but these are made of plastic, so they will not be rigid enough for the delidding. And typically you also have them made out of like aluminium, for example. I don't have them here, but I ordered them, so I will have them next time. That's why I have to use those like precisely grinded steel blades, which you're not supposed to use it for. Back then when I did my apprenticeship, they would have killed me for doing that, but luckily I'm my own boss, so nobody can complain. That is actually a surprise. It's thermal paste, it's not soldered. And actually it was already enough cutting around the edge, we just probably would have used a bit more force. Not bad at all. The delidding was much easier than I expected because the CPU is not soldered. You can see still the thermal paste residues on the IHS, while I already cleaned everything off the package of the CPU. It's quite impressive, especially when you measure the die sizes. It's about 22.5 times 25.5 millimeter in length and width, which then equals about 574 square millimeters of die size. Compared to a bit older 7980XE, this had about like 480 square millimeters. The width is the same with 22.5, but it's a bit longer, it's about 4 millimeters longer. It's still somewhat comparable in die sizes, which is why I took this CPU for comparison reason. But if you check the amount of pads which are used, like connectivity wise, the Ampere CPU has a ton more. That's also why the PCB or the package itself is quite a lot larger. That's mainly because this CPU has this huge amount of PCI Express lanes, 128 for connectivity, which is required for having a good connectivity for a huge amount of devices and also for the dual socket compatibility. Yeah, so much about die sizes for CPU, but I find it very impressive like how tiny on what kind of surface or area you can pack AT cores. This was our quick journey regarding an ARM CPU. It was also the first time that I ever used one or tested one. It was quite interesting, maybe also quite interesting for you, maybe also the first time that you saw some kind of footage regarding ARM CPUs on servers. By the time this video will be online, there will also be the dedicated root server available by Hetzner, which will feature this 80-core ARM CPU. If that's something for you, definitely make sure to check out the link in the description below. And thank you very much to Hetzner for the possibility and also the access to the CPU. I mean, just being able to test this is one thing. And then also to get, I mean, in the end, this is a 4,000 euro CPU, right? And to get one of these with us home and be able to delete it, just to check what's inside, it's very impressive. So thank you very much for the cooperation and the possibility for testing and also getting the CPU. It's been like 2 months that we shot the video, and these servers are finally available, so we can also finally publish the video. Quick update at the end right here about the server situation on the Hetzner website. So you can find these under RX branding. Both servers come with the same Q8030 CPU that we saw in the video, but the RX 170 will cost 169 euro per month and will have 128 GB of ECC memory and two 960 GB SSDs. The bigger RX 220 will have twice the amount of memory and dual 3.84 TB SSDs and costs about 219 euro per month. So I hope you enjoyed this video and the quick journey into the ARM sector. Thanks for watching and see you next time.